Hello and welcome to chapter 15 of this Flutter course. In previous chapters, we talked a lot about setting up our project. So we've so far been working a lot with setting up the project and the basics. We also created our login and register views in our Flutter application. As I was developing this course myself, I got to the point that there was a lot of code being written by me, and then I needed to make sure that it is stored in a place where I can always go back to, even if I lose this information on my computer, that I can go back to that place and then retrieve that code. So if you're a software developer, if you're a seasoned software developer from before and you know what Git and GitHub are and you're comfortable using them and you know how to set up, for instance, your secure keys with GPG, then you can safely jump over this chapter. But if you're a designer, product owner, product manager, whoever, who doesn't know what Git and GitHub are, or maybe needs some help setting those things up, then this is a good chapter for you. Otherwise, you can just skim quickly over it. So let's talk quickly about what Git and GitHub are and why we need them. As I mentioned, when you're working with your code, for instance, as I was while developing this course, then you're writing a lot of code, which is, intrinsically valuable because your time was translated into those pieces of code. As you were writing the code, you spent some time and energy and effort and wrote the code. So it is quite an important piece of information for you just to lose. And depending on the type of project you're working on, for instance, this project, it has taken me quite a lot of time to even develop the idea of the project and put it together. So while I was putting together the idea of the course and writing all the bits and pieces that I have to explain in every video, I made quite a lot of backups of those ideas, because had I not done that and had I just put everything in just one piece of paper or something, or just even one digital document on my computer, had I lost that document, then, well, yeah, I would have lost it and I would have had to begin from the absolute beginning. And this is the same thing for your code. So you need to use two services called Git and GitHub in order to store your code in a safe place so that you can always retrieve it later. So let's talk quickly about what is Git. Why do you need this? So what you need to know about Git is that Git is a piece of software on your computer that allows you to manage various changes that you make to a code base, such as our project, at different times, keeping track of the date those changes were made, the person who made the changes, and the changes themselves. And also, it will be able to provide you the difference between your recent changes and what was already provided or what was already committed into this Git repository. Well, what a Git repository really is a bucket, is an empty bucket initially where there's nothing in there. And as you interact with your source code, then you'd be like, okay, now I want to turn this source code that I've written into a bucket. So then there's a bucket created around your source code called a Git repository, which keeps track of all the changes that you're making, or anybody else that works on the same source code is making to the code, and it will allow you to save snapshots of those changes at specific times of your choosing. If you're a designer and you're working with Figma, for instance, Figma already automatically saves your work at the times that it sees fit, so you never have to press really a save button. And also Figma, if you've seen it, it keeps track. It has a version history. So you can literally go to Figma and say, okay, I've done my work. I want to actually commit my changes in the version history and I want to give it a name. Most designers don't do that, and they let just Figma save their work automatically. And by that, the Figma just says, here's the timeline of your changes. At this time, you did this. At this time, you did this. So even if you're a designer, you're implicitly using something called a version control, which in that case is Figma. But when you're coming to the software development world, where you're working with your Flutter application, there is no Figma there, and you're working with raw code. So you're going into Visual Studio Code or Sublime or whatever text editor that you're using, Android Studio as an IDE or whatever, then there is no service sitting there and saying, oh, you made some changes, let me help you save it in some sort of a cloud solution. So the system that allows you to do that on your computer is called Git. So Git is a software that allows you to keep track of changes that you're making to source code. Okay. So I can see here that before we continue, we're going to actually talk a little bit about Git. So what I'm going to do here, I'm going to ad lib a little bit here and improvise. And I'm going to go here and make the screen a little bit bigger. I'm going to bring up terminal. You don't see it on that screen because it opened on another screen. So let me just increase the size and bring it up here so you also see it. So I'm going to go here to my development folder, and I'm going to go to my projects, and let's then go to make a folder. I'm going to say Git. Okay. Should I call it Git, or just let's actually create a folder called testing? Okay. Let's go into testing. Then it is an empty folder, as you can see for now. And what we're going to do is we're going to tell Git now, which is a software installed on my computer, to tell it that, okay, all of a sudden I want to turn this empty directory here into something called a repository. Remember, it's going to be a bucket then that keeps track of changes in the current directory. Now, before we continue, maybe, oh, sorry about that. Maybe you also need to actually install Git on your computer. If you're not coming from a software development background, you probably don't even have Git installed on your computer. So I'm going to bring up a browser window here and say install Git. So if I Google install Git, you will see that there's like information how you can install Git on your computer. If you are on a Macintosh and you have already installed Xcode, Xcode comes pre-packaged with Git already. If you're on Windows, I believe that you actually have to. I have a Windows machine right here next to me, which I use daily. I believe for Windows, you'll have to install Git personally, like manually. So let's say install Git Windows. Git download package Git and Git guys install Git. Oops, my iPad for some reason got disconnected here, so I'm gonna have some difficulty then. Let's see now. Install Git on Linux. Okay. I believe there is a good package actually for getting it on Windows. Let me go back here. Installer on Windows, you can see here. Just go to, I'm gonna increase the screen size a little bit as well so you can see it a little bit better. Here it says go to https git scm.com download win. So I'm gonna go here and it's gonna start downloading. So I'm just gonna say cancel because right now I'm on a Macintosh. So here is where you can download Git and install it on your computer. If you're on a Windows machine and you have the Linux subsystem, which I do on my Windows machine, then you may actually want to download Git using sudo apt on that Linux subsystem. But it is possible that the Linux subsystem on Windows already comes shipped with Git, so you don't have to do anything. I wouldn't be surprised if Git was one of the absolute core components that was shipped with Linux. So that's for a Macintosh. And also, if you're on a Macintosh and you don't have Xcode for whatever reason, then you may need to also download Git separately. So let's go back here and see how you can do that. If you say Mac OS here, it says there are several ways to install Git on Mac. These are probably install the Xcode command line tools, which we've already done. So if you don't have it installed already, it will prompt you to install it. So otherwise, you can go in here, get scm.com download Mac, and then you can do brew install Git. So if that is what you want to do, then you first have to actually install Homebrew. So go into this link and say Homebrew install. Basically, just do as it says here. You see, there's the command. And then go and install Git using Homebrew. And if you're on Linux, then sudo apt install Git. I think maybe you don't even need to have sudo if you're installing for the current user. So just apt. Is it get or install? I've forgotten. But there's information about Linux here as well. Apt install, yeah, git all. So yeah, I'm assuming you're kind of like on a Debian based distribution as well. But otherwise, there's information here how you can install it otherwise. So, all right. That was a lot of information. And before we continue, I'm just gonna try to make sure that I'm connected back to my to my iPad here, because on my iPad I keep hold of all the information that I have to provide to you in some sort of like a chronological order. So it is very important for me to actually get my notes up there. So I'm gonna try to connect to my iPad, and yeah, there it is. Okay. So now that I'm assuming that you've installed Git. I'm assuming that that is done. If you say which Git, then it's going to tell me in this case that user being Git. That's where Git is installed. If you're on Windows, to be honest with you, I don't know the command on Windows to know whether like Git is installed. But on Windows, all you have to do is just to type Git, and if you see that it throws an error, it says Git isn't available. Either you haven't installed Git, and if you have installed Git, maybe Git isn't in the current path. So you'll have to go and adjust your environment variables in order to get Git. And there's lots of information on the internet. So we're not going to focus right now on how to install Git exactly, because that's going to be like its own course maybe. But if you follow the instructions that were provided on the website that I just showed you, you should be able to get far. So I'm assuming now Git is installed on our computer, and you can see here we're in a folder called testing. So if I say where that testing is, you can see that is right here. Now, what we want to do is to say testing, for instance, is the project that we're going to place all our code in. Okay, so there's going to be information that we're going to write here in this folder. There's going to be some Dart files. There's going to be some PNG and JPEG files. There's going to be our application icon, all that stuff, and we want to store this safely. So the first thing you may want to do is to basically tell Git that this current directory in itself is a Git repository. So the bucket, remember the bucket is going to wrap itself around the directory. So if I get the contents of this directory at the moment, you can see that it's completely empty. But if you want to create a Git bucket or a Git repository around this directory, all you have to say is just to say git init dot. Okay. You'll see here now it says that initialized empty Git repository in this folder. So now if I get the contents of this folder, you'll see that there's a new directory called .git. And .git directory is where Git basically keeps track of its internal, like the changes to this directory and like what you save, when you save it, who is it that saved the work, etc. So now that you've done that, now you've created a Git repository basically around this empty directory, you can issue various Git commands such as git status. This will give you the current status on this directory. And you can see here, as soon as we created a Git repository with Git in it, all of a sudden my terminal changed my prompt here and said that all of a sudden testing is not just testing anymore, but it's actually a Git directory, and we're on a branch called main. Now, I don't want to talk about branches right now, but just know that there are yeah, let's just not talk about branches right now because I'm planning to do that a little bit later. So what we are going to talk about is this little message here that says no commits yet. Now, in Git, whenever you're working, Git doesn't just save your work automatically. You need to tell Git to save your work. And those points where you save your work, they're called commits. It commits, as its name indicates, is you committing your work. You're saying, I committed to this and I want to save it. And that's, I mean, it could be called save, but save is maybe, it could be like read as kind of more like a verb, like, oh, am I gonna save it now or what is it? But if I say here's my commit, then it could be a little bit easier to infer that, oh, it's a piece of information that you've saved and you've committed to. So I think maybe that's the reason it's called a commit. I'm not sure. So those commits are points of time where a person that has access to this repository saved their work. Okay, so just remember that that is a commit. And if we see here, the status says no commits yet, because there was literally nothing that you told Git to save. Now, what we're going to do is to open up Visual Studio Code. So I'm going to bring up Visual Studio Code here, and you can see this in an empty folder. And I'm going to create a file here, and let's just call let's call this info.txt, so just text file. Okay, so here's an empty file, and I'm just going to type hello in here, increase the size a little bit as well so you can see better. So now if I say git status here, you can see all of a sudden it doesn't say no commits yet. It well, basically it says that, but it also says untracked files, and it puts the info text right here. Now let me then explain what a tracked file and an untracked file is. A tracked file is a file that you've told Git about before. So it's tracking the changes being made to that file. Untracked file is a file that you have not told Git before about. So it says, oh, here's a file, you're doing something with it, but I'm not going to even look at it. I'm not going to keep track of it because you didn't tell me to do so. So, and things, I mean, yeah, a file basically can be in 3 states in Git. Right now, you've learned 2 of them, either tracked or untracked, but it could also be in another state that I will show you soon. So now you can see there's a message here that it says, let me bring actually the terminal a little bit up here so you can see the terminal in its entirety. It says use git add and then the name of the file in order to include what will be committed. So let's do that. I'm just going to say git add info txt, and now I'm going to say git status, and all of a sudden you'll see that Git understood that here's a new file. You're committing this file called info text, but you can see that it still says you haven't committed anything, but it says changes to be committed, and all of a sudden this file is green. Remember, I said a file can be in 3 states: untracked, which means Git doesn't know about it; tracked, which means Git does know about it; or it could be staged. So if you see here, this file is green and it says changes to be committed. So stage is where you have made changes to a file and you've told Git that you want to commit it, but you haven't committed it yet. Now, you may be asking, okay, why would I have files that aren't going to be committed? In some projects, if you have some information, for instance, if you're working with 10 other developers and you're making some tests and you're writing some code in the directory where your source code is placed at, but you're not really ready with that file yet, you don't want to commit it into a branch where everyone else sees, then you could say, oh, I'm not going to commit this, it is not staged file, I'm not even ready for staging it and putting it into commit. So in that case, you're not going to add it to the staging area. Okay, so remember that. Now that you've done that, you just said git add, you can commit it. And a commit literally means that you're going to save this work in Git, okay? And the way to do that is using git commit, and then you will provide a message using -m here, and then quotation marks, okay? So here you will write a message that will be appended to your entire commit. So what we're going to do here is says, let's just say add new info txt file for fun, okay? And then I'm just going to press enter. You can see here it says 1 file change and 1 insertions, and it will say that, yeah, it has created this file, okay? So I'm going to clear my terminal now, and we're going to do git status. All of a sudden, that message that about no commits yet disappeared, and all it says is that you're on a branch called main, and there's nothing to commit, okay? So what do you do then if you want to see the commit that you just made? Like if you want to see, okay, what are all the commits that were made? Then in that case, you can say git log, and git log will display all the commits that were made and who they were made by, and you will also be able to see the date they were made and the commit message. Do you remember we said git commit -m? So that was the message provided in the git command and then saved in the repository. Okay. So that is the message, and that's the email of the person who basically did that commit. Now, I jumped over a little bit here, and to be honest with you, that was, I didn't really think about that. Some people, if you're installing Git, then you're not going to have all this information already set up, like who you are. And there's information about how you configure Git and how you tell Git who you are and what your name is, etc. And that is using a command called git config and global, for instance. but you could actually read about that online. So just say git config, and then you will get a lot of information about how to do that. So, but just know that Git is such a big world that if I wanted to explain everything about Git, we could have a course that is already 30 hours just talking about Git. So just know that there's constraints for on me to explain like the absolute basics of Git to you in order for us to be able to use Git in this course for this particular use case. So I'm gonna just focus on those things. Okay. So now that you know how to commit, I think you're like you're in good place to start learning more about Git. And the thing you may want to know also, which we're not going to use in this course, is branches in Git and why you'll need them. Now, Git is a piece of software that allows groups of people work on the same piece of code without losing their changes. Now, if you're, for instance, from a design background, if you're working with Figma, if I go into the design file that you've shared with me as an observer, I cannot make any changes. So I can only observe you, and I can just like export assets, or even if you're using Zeppelin, it's the same thing. You can, so some designer is sitting with Sketch, for instance, and then they're exporting their work into Zeppelin, and then you as an observer, you're exporting that information from Zeppelin, but you can't make any changes to the source. However, with Git, when you share your information for like your Git repository with someone else, they can also make commits to it. As you'll see soon, we're going to use GitHub for that. So um, then basically you need to make sure that every person is identified correctly, and then they have, for instance, um, that they have configured Git in the right way. And sometimes, I mean, we're talking about branches, so sometimes these people don't want to affect what you are doing in this main branch. So just imagine a branch is more like a train line, like your train is going there, and maybe some places your friends want to visit a town in the city that you hadn't planned. So they get off the train, they go on another train line, and at the end you will meet. So at that point you can see that they branched out into their own branch, and that is like the concept of branches in Git as well. So sometimes when you're working with other developers, they may want to branch out into their own branches on the same source code, do some experiments, and once they figure out what they actually wanted to do, maybe they will save their own work into that branch, and then they will bring it back to your branch. At the end, you will meet at the train station, and then they bring the results with them, and then you merge together. So there's a lot of information about branches, how they work in Git, but just know that branches are kind of like train lines, and right now you're on the main train line going from your city to the destination. Okay. So but again, there's time constraints on this course. I can't explain everything about Git, but if you're interested, there's lots of great content available on YouTube that you can watch. And I'm pretty sure that there's lots and lots of tutorials online as well that you can go and read about as well. Wow, that was a lot of information. Okay. Let's now talk about what GitHub is. Now, GitHub is simply said a cloud service for storing your Git repositories. So um, right now this Git repository is sitting on my computer. So even if it is I'm committing my work, I'm saving my work, there's still no traceability from the outside world. So no one else is allowed to see this code right now. It's sitting right on my computer. And for that, if I want to share this code with other people and potentially allow them not to read only, but also to be able to commit and collaborate with me in the source code, then I would be able to share that on a cloud service such as GitHub. GitHub has the word Git in its name, but it's not the same thing as Git. So Git is a software that actually manages all your commits and etc. But GitHub is the cloud service that holds on to these repositories for you. So if you don't have a GitHub account, I'm going to help you do that right now. So let me close. Actually, no, I'm not going to close. I'm going to minimize this and minimize perhaps. Yeah, let's close this window. I don't think we're going to need it. So I'm going to bring up a window here. And I'm going to go here and look at this website, github.com. All right. So what we need here is that for you to create a GitHub account. And to do that, you'll need to go to this website that I will provide for you right there, github.com/sign up. Okay. So if I bring up a private browsing window here and I say sign up, you will see that, yeah, it won't know that I'm signed in already with my other account, and it will ask me to start signing up right here. Okay. So this is like the main window for the sign up of GitHub. And they've done it a little bit comically. It's kind of like a Star Wars kind of theme. I don't know what you want to call it, but here you will go through a few steps in order to create a GitHub account. Okay. So I'm not going to do that simply because I've already done that. But in your case, we'll just need to go through this, provide your email, choose a good secure password for your email, for your GitHub account. And then at the end, you will have a simple GitHub account, okay, as I already have. So we've talked about already setting up Git in the terminal. So I'm not going to talk about that. I'm just going to maybe move this a little bit up. All right. Now, after you've set up GitHub on your, basically after you've set up a GitHub account, you will need to set up something called SSH keys. Now, this is a little bit technical, but and it is nothing that you can jump over. It's not like you can actually commit your work without setting up SSH keys on your computer. You can always go to GitHub and actually commit your work right on GitHub itself. Like you can write some text and then change that text right in the GitHub interface, like the web interface. So then they will do all of that work for you, because they will commit it from kind of like their own SSH keys, I believe. But if you on your computer want to be able to commit your work from your hard disk or your SSD or whatever into GitHub, you will need something called an SSH key. SSH keys are how should I say it? Is cryptographically even let's see, cryptographic? No, cryptographically. I don't know. Yeah, cryptographically signed. These are cryptographically signed pieces of signature that will just kind of like private keys that we worked with when we worked with keychain in one of the previous chapters. They allow you to identify yourself as a person or as a committer. So I think that does make sense. So, and apologies again for the hiccup of cryptographically. It's just because I'm not a native English speaker, so you should be expecting these hiccups every now and then at least. So an SSH key is a piece of key that is a signature that you as a developer or a committer of code create on your computer. And whenever you make a commit and you want to send that commit then to GitHub, then GitHub knows who you are. Okay. So it says, okay, you are person XYZ and you're trying to push your changes into this repository. I'm just going to make sure you have access to everything. Okay. So you need your SSH keys set up. So what we need to do is to go to GitHub, and I'm going to bring up a web browser for you to understand how to set up your SSH keys. So let's say GitHub sets up SSH keys. And you can see adding a new SSH key to your GitHub account. So there's a very, very comprehensive guide here on how to set up your SSH key. So you can see that it says, let's see, generating a new SSH key and adding it to the SSH agent. So this is where you want to go, okay? So after searching for GitHub setup SSH keys, make sure that you at the end go to this link, generating a new SSH key and adding it to the SSH agent. read through this. There's a very comprehensive guide. There are only a few commands that you have to issue in the terminal, so do them precisely as it is specified here, okay? So after you've done that, then what you'll need to do is to add that SSH key, I believe, into your GitHub account. You see, as the link provides here, adding a new SSH key to your GitHub account. So you can see here, then it says, okay, do this command, and then go to your GitHub account, settings, and then go to SSH and GPG keys, and then say new SSH key, and then add that information in here, okay? And then press save, and that's it. Then you have your SSH key all set up and done. So these are the two things you'll need to do: create an SSH key and then upload the public key into GitHub. And again, because of constraints on this course, I can't explain this like line by line to you. I'm just providing you the information that you need to know, and I kind of expect you to do these things on your own, okay? So that is that. Now, we also need to talk about GPG keys. And let's actually, I think GPG was GNU Privacy. What was GPG? GNU Privacy Guard. So it's a piece of software that you download on your computer. You can see it's a free software replacement for Symantec's PGP cryptographic software suite. It is compliant with RFC, blah, blah. All you need to know about GPG and how we're going to use it in this course is that where you have your, I mean, we talked about SSH keys, where you have your SSH keys and then you, and I know this is a little bit geeky, but that's kind of like the nature of this thing anyways. And when you sign your commits with your SSH key, with your private key, and then you push your changes to GitHub, and GitHub just verifies, okay, this commit is coming from someone who has access to this repository. When you create your GPG keys and then you sign your commits with the GPG keys, then that actually verifies that you are who you say you are. So a lot of software developers are still continuing with SSH keys, and to be honest with you, that's not good enough. I mean, well, it depends kind of on your opinion, but in my opinion, it's not good enough, because anybody getting a hold of your SSH keys can literally just do anything they want with your commits and change anything they want. But with the GPG keys, you'll ensure that you are who you are, and anyone else, even if they have hold of like your SSH keys, their commits won't be signed as you. So let's now talk a little bit. I'm going to take some items here and just make sure that we've talked about them, about SSH keys. Now we're going to talk about GPG and what you actually need it. So there's a little link here. I'm going to open that link here so we can both see it. And it says Git is cryptographically still, this word is a little bit different for me to say cryptographically secure, but it's not foolproof. If you're taking work from others on the internet and want to verify that commits are actually from a trusted source, Git has a few ways to sign and verify work using GPG. Okay, so what you need to do is you need to set up GPG basically on your computer, and I believe if you just say GPG install Mac or GPG install Windows or whatever, then you can come to, for instance, I'm using GPG tools on Mac, and you can actually install GPG for various operating systems, for instance, Windows or Linux. So just Google GPG and then your operating system. So for instance, GPG, if I can spell, if I can smell GPG, and download GNU PG here, and you see, so this is like the download tools for Windows, I believe. Let's see. And you can see here, you could use GPG for Win, full-featured Windows version of GNU PG. So all I'm trying to say is just to download a piece of software called GPG for your operating system. So whether it's GPG for Win or GPG tools for Mac OS, or if it's like for Debian, GNU PG is part of Debian. Okay, so it's already maybe built in, so you don't have to do anything for your Debian-based Linux operating systems. All right. So after doing that, then you'll need to set up GPG for GitHub. And I'll provide a link here for you that you can read about. It says managing commit signature verification. And the link, I'll open it here so you can see how it looks like. And you can see here generating a GPG key. So you can first go there and it will help you through the various steps that you need to take in order to create your GPG keys. It's very easy. It's just a few lines of code or a few lines of text that you have to issue in your terminal in order to create your GPG keys. Okay. So after you've done that, you need to make sure to go into this section, add a new GPG key. We've done that. And then you go here to your settings, you can see SSH and GPG keys. And then the same way that you added your SSH keys, you'll need to add the GPG key in your GitHub account, okay? And after you've done that, the difference between an SSH key and a GPG key is kind of like you need to tell Git that you have a GPG key, and then it needs to sign your commits with your GPG key, okay? And that's where you go into this tell Git your signing key, and you need to just follow these steps to tell Git using the git config global user signing key you see here. Okay, so just follow these steps. To be honest with you, I don't think you need to associate email with GPG key really right now, but if you want to, you can do that. So I'm kind of like assuming that you've already done that for your computer, in that you've created the SSH key, you kind of know a little bit about Git, you have a GitHub account now, you have created your PGP keys, and then you have told Git about your PGP keys, so your commits are actually signed. Okay. So the next thing we need to do is to now, and you see, we've been working on our notes application, my notes. I think it was the project was called My Notes here, if you remember. And if I say git status here, you will see that it says not a git repository. And that's kind of a little bit sad because we've written quite a lot of code, but we haven't really backed it up in GitHub. Okay. So what we need to do now is to go and create a GitHub repository. Remember that bucket? We need to create one of those buckets for our code. So let's go. I'm going to create a Safari window here, or Chrome or Brave, Firefox, whatever you want to use. And I'm going to go to github.com. And I'm going to go into repositories here, as you can see, and I'm going to say new. And I'm going to give it the name My Notes. All right. I'm going to increase the size of the window so you see it better. For the description, I'm going to say My Notes Flutter application. And you can see here that tells you, it asks you if you want to create a public repository or a private repository. And the difference here is that if you create a public repository, everyone can by default read the content that you're creating. Usually, if you're not 100% sure what public means, create a private repository, because usually there's lots of information that you may want to create, like a private information with some API keys. So you want to probably create a private repository unless you know exactly what you're doing, or if you want to, for instance, contribute to open source projects and create an open source project from the absolute beginning, then you go and create a public. But you can always make your private repository public later. And you can always make your public repository private later, but that doesn't happen that often. So it's probably a good idea to create a private in the beginning, okay? Then in here, add a README file. A README file is pretty much just a file that will be displayed to whoever goes to your GitHub repository and looks at just the index file of the GitHub repository, so you can place some information in there. But it's usually a good idea to do that. You don't have to, but I suggest that you actually do that. And then say, excuse me, and then say add git ignore. And we haven't talked about git ignore before, but what git ignore is, as its name indicates, is a file that dictates to Git on your computer or on the computer of whoever has cloned your repository about what files should not be committed to your Git repository. So usually it's a good idea to have a git ignore file. And in here for the template, just choose Dart. Okay, Dart. Okay. And in here, you don't have to choose license right now because you're probably not going to share this code with anybody as it is right now, but you can always add a license later. Okay. So I created a private repository, some name, which is my notes. Sorry, yeah. I'm actually for the for the name of the repository, I'm going to change it just to lowercase. I with no spaces, just my notes, okay? And then I'm going to say create repository. Boom. So as you've done that now, you will see that you have a repository here, and I mean, there's nothing really in it, okay? So what we need to do now is to, you see, we have our code here, and then we have a repository. How do we put this code in there? You may think, okay, I'm going to upload all the files by hand, or like go and drag files here. You could kind of actually do that, but it's not a good idea. And so what you need to do is just tell Git now all of a sudden that, hey, this folder here is indeed a Git repository. Remember from what I said before, so you need to say Git init. I'm going to bring up the caption so you know what I'm talking about. Git init, and then you say git init dot, okay? All of a sudden, this became a repository. So if you do git status, you see, let me see if I can actually change the arrangement on the screen so you'll see more of the screen real estate. And perhaps I could even do something like this. Is that a better idea than just doing this? No, probably not. So this is better. Okay, this is a little bit better. So you see now it says, now that you're a Git repository, I can see that you have a lot of files that you haven't really committed. And what we could do then, we could say git add all these files and folders to my Git repository. And then I'm going to say git commit with the M as a message, my initial commit. Okay. See, now if I say git status, it says there's nothing to commit. Now I want to kind of push these changes. I want to send these changes to GitHub. Well, how do I do that? Because if I say git push, see, it says, oh, I don't know where to push these things to. So what you'll need to do now is to go to your GitHub repository and then go to code and then grab this guy from here. You see, to the code, to SSH, and then copy this and then go in here and do what it says here, git remote add. So I'm going to say git remote add origin. It's the name of our remote, for instance, and now I'm going to add that. If I say git push, it says, okay, now that you've done that, you still need to tell me that this main branch, which is on your local computer, is actually mapping to the main branch on GitHub, which is right here. So you see, here's a main branch, and we're also on the main branch. So you don't have to do this complicated code. You could actually say git push u origin head, which to me is a little bit cleaner, and that will do the same thing for you. Updates were rejected because the remote contains work that you do not have locally. This is usually because it's actually great that we got this. So I hadn't planned for this to happen, but what is happening here is that you see, if I go into this GitHub repository and then I can click on this initial commit here, you will see that when I created the repository and we chose all those, README file and the git ignore file, these are files that are literally created on GitHub using GitHub by GitHub and placed inside this repository. So that is a commit. You see, it has its own commit ID. Now that commit is sitting there in that bucket over here. So there's a commit in its own bucket. Okay. Now we have our own computer here with its own bucket and its own commit, but all of a sudden we're telling this using that git add command that I said. What we're doing is that we're making a connection between this local repository and the server repository and saying that any changes that happen here, we want to push them over here. And when we said git push, these changes were rejected because it says, oh, you have changes here at commit and you're putting them in here, but your changes, your repository here didn't contain the changes that were already there. So it's saying that there's a conflict. I don't know what you're trying to do. Are you trying to replace the contents that were over there with your stuff? And to be honest with you, that could actually be the case, because you see what we did here. We have a git ignore file here that was created for us by GitHub. And also we have our README file, which we probably actually don't need, to be honest with you. Maybe we don't need that. And also the git ignore. But if you looked at the changes that we're committing here, if I say lsla, you will see there already is a file here. It was called gitignore here, you see, which was created by Flutter. When we created our project, Flutter already added that. So let's say cat gitignore to see its contents, and you'll see there's lots of stuff that Flutter has already created for us that says these things need to be ignored. So what I'm trying to say is that all these things that exist over here, we don't need them really. So what you could do is say git push f, and I believe that force pushes git push u origin head f, which force pushes everything. Okay, so I'm going to clear that now, and I'm going to go to my notes repository, and all of a sudden you see that here is, you see, and oh, we already had a README file as well. So Flutter has created a README file. That's amazing. I didn't know this, so I learned something. That's pretty cool. All right, there we go. So now we have our code basically pushed. So that is for our commit that is already placed there. I'm going to just tick some items here that I've talked about them. Great. So that is already done as well, pushing. So now you have your changes over there, okay, on GitHub. Now what we need to talk about is also tagging. In this course, I'm going to use a feature in Git called tags. A tag is, just as its name indicates, it kind of is a label. So as you become better and better at software development, you'll understand that some places, sometimes during your journey as a software developer, the code that you wrote means a special thing to you. For instance, you may say, after a whole weekend of work, I could finally deliver like the verification Flutter screen to my users, and that in itself, in its essence, has a special importance. It has a special meaning, and you may want to tag it. And by tagging it, it means that I'm just going to give a special name to this. So in the future, if I want to go back to that point in time, I don't have to go into my Git log and look at all my commits and see which one was that special commit, but I also want to like give it a special name, okay? And that name is an annotated tag, or a tag that has a message applied to it. All right. So that is in its essence what tagging is. So you're giving a name to your work, basically. So what we need to do now here is to tag our work as step one. We've done a lot of steps up to this point, but none of them has been so like important that we actually had to commit yet. But I think this is important enough. Now we have a register screen and a login screen so that we can tag it. So the way to create an annotated tag in Git, you will literally just say git tag. Okay. So let's go in here and say git tag and give it the name of step one. All right. Now you can see if I want to push these tags to the back end, to GitHub, because those tags don't exist right here, right now. And what we could do is to say git push tags -- tags, and this pushes all those tags to the server, which is GitHub in that case. And to be honest with you, I don't really know. Oh, here, one tag I can see all of a sudden here, tags, and step one is created there. Okay. So what we could do also is that after we have our GPG keys all set up, we also can confirm that our work is truly signed. If I go to my notes here and then look at this commit, let's see if we can see that information somewhere here. Can we see all our commits somehow here? If we go to this timeline, oh, it's not showing me that information right now. Yeah, but anyways, you could have a look at whether your commits are signed by a little badge, which I can't see right now. So maybe there's actually something wrong with my PGP keys. So if you've done all the PGP key installation correctly on your computer, then you should see all your commits being signed and actually displayed here, but with some sort of a badge. But I can't unfortunately see them. Maybe GitHub has changed that interface so that we can't see our verified badge for our GPG keys yet. So All right, we talked a lot about Git in this chapter. So I think that's actually quite enough for this chapter and Git. We've talked almost 15 minutes about Git, to be honest with you, and that's sufficient. Now that we've got Git set up, what we're going to use it for in the upcoming chapters is whenever we do something significant that needs to be saved, we are going to commit that change and also tag it and send both our commits and our tag to GitHub so that it's stored securely in some sort of a cloud storage, basically. So that's how we're going to use Git and GitHub in this course. And I thought of it as so important for every software developer to know that I thought if anybody is watching this course who is not a software engineer before, then you definitely need to know about Git and GitHub before you can continue. So what we're going to do in the next chapter then is to talk about email verification. We've done login, register screens, very simple, but we haven't done the email verification yet. And that's exactly what we're going to do in the next chapter. So I'll see you there.